Now that we know how to find the differences for a matched pairs data set, differences letter D, then we know how to find the mean of those differences, D bar, and SD, the sample standard deviation. We're going to use those values in order to find a hypothesis test on those differences, namely about the mean of those differences. So this is going to be a hypothesis test regarding the difference of two means, but only for matched pairs data. This isn't going to work any other way. Now, the requirements used to conduct this sample or this test are the simple random sample of size n. The sample has no outliers and comes from a population that is normally distributed, or you could have n be greater than 30. If n is greater than 30, then you don't need to check that it's normal. And then you need your sample size, as usual, to be less than 5% of your population size in order to ensure your samples are independent. Now, a lot of times we don't bother actually checking these because we're in a class that's all about running the test. But in real life, you would want to check these every time because if you don't meet these criteria, then you really shouldn't be conducting a hypothesis test at all. All right, so let's look at step one. You're going to determine your null and alternative hypotheses. Now, these are structured about mu d, the mean population difference, or the population mean difference of the matched pairs data. So if you notice, they look actually quite similar to what we learned in chapter 10, when we learned t-test back then, which is that mu is equal to mu 0, mu not equal to mu 0, and so on. The thing about these tests is that your null hypothesis, is always that you have 0, because you always assume that there is no difference between the two groups. If you have no difference, then when you subtract them one from another, you should have 0, right? That would be no difference. And so that's always your null hypotheses for these. Then the alternative would be mu d not equal to 0 for two-tailed, less than 0 for left-tailed, greater than 0 for right-tailed. Step 2 is just like it was before, your alpha. Then step 3 is your test statistic, and this is a slightly different formula than you've seen before. D bar is in place of XD now, and then you have SD instead of S. And this, of course, follows the student's t distribution because it uses the letter t. That's kind of obvious, with n minus 1 degrees of freedom. Now remember that D bar and SD are the mean and the standard deviation of those differenced data. It sounds like it's incorrect, but it's actually correct. All right, then you follow the same methods you did in chapter 10. Pretty much these steps are exactly the same from chapter 10 that they are, or from chapter 10 in chapter 11. So there's no difference in the two chapters there. All right, so there's the instructions for it with the calculator. But before we get into the calculator, let's do some setup questions to set up this hypothesis test. So continue with this Reiki touch therapy. We want to conduct a test of whether there has been a mean reduction in pain. That word reduction I highlighted because it's important. After the Reiki therapy. So they want to reduce after. So using a 0.05 level of significance. Keep in mind that the differences were found as after minus before. So if you want the after to be less than, we're setting up group 1 is after, group 2 is before. We want to know if after is less than before. That's how this is going to work. In other words, is group 1, which is the after group, less than the before group, which is group 2. Now the null hypothesis is pretty easy to figure. You always have it so that mu1 is equal to mu2. You always assume that the two groups are similar. In other words, after and before are the same. So what if we subtracted before from both sides? If you subtract mean from before from both sides, this value right here, you subtract it from the right-hand side and the left-hand side. Over here, if you subtract it from there, you're going to have 0. Mu before minus mu before would be 0. And then you'll have mu after minus mu before on the left. And then because this is matched pairs data, we abbreviate this down to mu d. D for the difference between after and before. All right, then for the alternative hypotheses, then you say, I want mu after to be less than mu before. You don't have to use the numbers 1 and 2. We always use those in the setup because we have no way of talking about what you were actually working with. But if you actually know what they are, like husband versus wife, after versus before, group 1, group 2, you can actually write in those words instead. So I want mu after to be less because I want a reduction in pain. So I want after to be less than before. That would be mu after minus mu before is less than 0. In other words, the mu d is less than 0. And that would be my alternative hypothesis. Now notice if I had set it up for you, because I set up exactly what I wanted. I said back on 3 pages ago, that I wanted it to be after minus before right here. Now if I had set that up to be before minus after, if I had reversed myself, what would have happened to my hypotheses down here? If I had said it's before minus after like this, I'll make it pink, then it would have been mean before was group 1. I want that to be greater than the mean after because I want the after group to have less than the before group in terms of pain. And that would mean mu d is greater than 0. So this means it's going to be a little bit difficult sometimes to figure out, are you talking about a left-tailed test or a right-tailed test? You're going to have to be careful because if I set it up after minus before, this is a left-tailed test right here. If I set it up as before minus after, it's a right-tailed test, right? They're not the same. So you're going to have to be really, really careful which kind you're doing. So be careful when you're setting up your hypotheses and pay close attention to which one is group 1, quote unquote. So I set up after to be group 1, and that sets up my hypotheses to follow. All right, now what results do we expect from the hypothesis test based on the box plot of the before and after pain levels? So I have a box plot here, and I just wanted us to get a sense of what we're doing here. So here's the pain levels for the patients before, and then here's the pain levels for them after. So you can see that we expect to show that there's a significant decrease in pain level because look at how low the after group is compared to that before group. Look at the median for the after group right there in the middle, that line in the middle of the box. It is below, it's almost below the minimum of the before group and is definitely below Q1 of that before group. So we have a significant reduction in pain. It appears that we are going to reject the null hypothesis. So we expect to reject the null hypothesis. We don't know for sure, but that's what it looks like because it looks like there is a significant decrease. All right, next. They gave us the following normal probability plot of the differences, right? Is conducting a hypothesis test on these data possible? Explain. All right, so let me remind you, when we're doing this, we really want to talk about all 3 requirements. They're just giving us a graph for one of them. So the first requirement was, is it a simple random sample? Answer, yes. It was given in the setup of the problem. Let me flip back to the page. Here's the problem. Okay, so they say right here, it's a random sample. See that? Since it's a random sample, that means that we have a simple random sample. All right, I got back to the problem. So the next thing we need to know is n greater than 30 or greater than or equal to 30, excuse me, or is the data set normal? The answer is yes, because that's why they're giving us this graph. This graph shows, at left, shows that the distribution is normal. So it's okay that n equals 13 is less than 30. That's all right, since we know that the distribution is normal, and that's what we really need. Okay. Then the last but not least one, here are the 3 conditions. Is little n less than or equal to 0.05 capital N? Absolutely it is, right? Now, you don't really know this, but Reiki touch therapy has been going on a while, so there's lots of people that have had this. And that means 13 is far less than 5% of all the people in the world who've ever had Reiki touch therapy. All right, so now we know we've met the requirements and we think we know where we're going to head with our hypothesis test. I don't want to start the hypothesis test in this video because I won't be able to finish it. So let's stop right here, and then the next video we'll pick up and start running the test.